everyone doing out there? All right. Let's see if I can get this. There we go. That's better. All right. Here we go. Greetings, programs. This is Let's Code a Full 90. We'll take the next hour and a half, dig into some source code, and try to make the world a little bit of a better place. I'm your host, Rob Minching, and today we're working in the Wix toolset, as we have been for the last few weeks, many times. Last week we had a bit of a doozy. We ended up digging deep into the code, or rather trying to figure out what was going on with a whole bunch of timestamps. So I'll go back and try to walk through a little bit and remember where we left off. And I have some more data. As I promised at the end of that episode, I would go add some diagnostic code to try to help make to try to track this problem down. And I did, and I have that data. So we'll jump into that right away. But first things first, let's go ahead and bring up Visual Studio and look at the Wix toolset code where we left off. All right, so yeah, there we go. All right. Yeah, okay. Let's see. So this is my little class that I added called Hack. We're going to see how Hack is used internal to the code. But if we go jump over to the bind database command, what we were doing was we were trying to figure out why on an incremental build, we were always getting rebuilds. And the answer was from our MS build log, which I can bring up over here. I have it open. Yeah, here. This is an example build log, actually from very recent, to show that the issue still is reproducing. Let's see. I'll zoom in and then I'll find the spot and then I'll zoom in. All right, here we go. This thing right here that's saying this file from the merge module is newer than the cab that it ends up in, which of course means that the merge module file changed, therefore we need to rebuild the cab. Except that's not what's happening because we didn't rebuild. And we found that on every other test, and this is what we saved for our last 2 weeks, on every other test that it's failing because this file is newer than the cab. That's really mysterious. It doesn't make any sense. And well, yeah, it just doesn't make any sense. So what did we do? We spent the whole last episode trying to track down different ways that timestamp could be set with like using procmon. Actually, we broke out procmon, which is kind of the tool of last resort in my mind in a lot of cases. I took a moment to try to blame it on the antivirus, but you guys in the chat convinced me that no, it probably wasn't just the antivirus. There's nothing indicating in the procmon log to say that antivirus is driving the fault. And as much as I want to blame antivirus for all installation problems, in this case, yeah, it probably isn't that. So what did I do? I went from here and decided to add a bunch of different code throughout the process. So this is where the MSI databases are being built, and everywhere that we are tracking files, so that's where we're keeping a set of files that come in, inputs or outputs or temporary files, I decided just to dump their timestamps, and I put a little header on top of them to say, hey, we got this far, here are the files that we have that we can do this. And inside this report timestamps, it gives us the path to the file, and then its creation time, last write time, and access time down to like super duper fine grained, what is this, thousandths of a second, thousandths of a second, something like that. Really far, and honestly, I don't even think the file system is that granular, provides that level of detail for us. So, well, hopefully from this we'd be able to track it down. I won't bore you. I got all this running, got it pulled out, and just before the stream, I was looking at the results of one of them. So if I bring up Visual Studio Code, we'll see that I have some log files here. Let me look at the, whoops, missed. Let's look at the log files first. The set of log files that are available here. All right, so this is looking at a folder that I dumped all the files in. These are small. Can I get bigger? I don't know that I can get, yes, I can. All right, great. So over here, you can see I have a timestamp file for core and then for Windows Installer. These two files go together because the core ended up doing some file operations and the Windows Installer backend did some operations. I decided to, well, I'd write both of those and I didn't have data to share, so they ended up writing their own files. But these two files go together from one build, and then here is a subsequent build. So if you remember the test that we're running, we do a build, it does a full build, and then we immediately after that do another build, which should be a purely incremental build and have no issues. And so we can look at the timestamps of the first build and the second build and see what's wrong, like why are the files wrong. And in this case, we're actually most interested in why is that merge module file newer than the cabinet file. So if we go back to our build log here, I'm going to close that one. This one, we can go digging for this file here, and we should see it in this ginormous dump of timestamps I have. So we'll close this. So over here on the left of this, we have the core and the Windows Installer build log for the first build, and then the core and the Windows Installer for the second build. Now we're really interested in the first build because what we found is that the first build is leaving us in a state where the second build turns into a full build, which it shouldn't. So if we could track down what is going on with the timestamps in the first build, we'll be in a good place. So you can see here at the top, it says, hey, this is after any binary Wix libs were extracted. And I guess there were no binary Wix libs extracted in this case. And then we have after cabinet files created, after cabinet files. So what I want to do is search in here for our merge module file. And we find it here after merge module files are extracted, which makes sense because this file comes from the merge module after merge module extracted. And if I go grab this code just to kind of catch you guys up on what I wrote in here, I said after merge modules are extracted, dump them here. So early in the processing, if we have any merge modules, we go ahead and extract their files using this and dump that and put them in a directory so that later on they can be put into the appropriate cabs or laid out as loose files, whatever the case may be. All right, so that's the merge module code after merge module is extracted. And what we have here is something that's interesting. If we slide over, we will see that this file, was created, modified. Wow, I cannot keep this on one line. I'll just highlight this way. Created, modified, and accessed. And if I highlight the timestamp, there we go. We can see these all happened at the same time. So the file was written all within this one thing. But what's interesting is that I'm actually dumping timestamps with multiple dots of precision, so subseconds, ideally. And this file doesn't have that, which of course is interesting. So if we go look at here, we can see that this happened, or rather, yeah, so we wrote this information at this point in time, 12:07:05, like I said, just before I started this stream. So about 30 minutes ago. And it was at this. So this is 05:39179. And if we look at this is at 06. So it decided to round up this number from 05 up to 06. And then we look at after cabinets created, and this is actually showing us where the files are being transferred and sent to. So here's our cabinet that we're going to be creating. If I remember correctly. Yeah, let's go ahead and make this bigger. Double click. Yeah. All right, so here's my cabinets being created. And notice its timestamp is nice and detailed, very precise at 5:12:816. So at 5 seconds, 5:12:816. And if we look at the timestamp of the header, then that 5:2:816 is, a few slices of a second after the time that we wrote this, which makes sense. The cabinet was created, and after the cabinet was created, and very, very soon after that line of code, we ask it to dump its timestamps. So this makes sense. This timestamp says, hey, this was after the cabinets were created, and the cabinet was created at this time. But if we look at this merge module, with its really long name, so I can't get it all on the screen at one time, it was created 06, and the timestamp is 05. So after spending all of that last session trying to track this down, I think we found our culprit. When this file is extracted by the merge module code, is being extracted without enough precision, and because this is being rounded up, it's later than this timestamp, and also then later than our cab that we create. So even at this point in time, this file, this merge module file that gets included in this cab for us in that very small window of process, we are always in a broken state, which completely explains all the behavior we've seen, except it does not explain the behavior of when it would work like every other time it would work. And I haven't tried to reproduce this without that, but my guess is that sometimes this gets hits on a border. So if this was to be rounded up, let's say this hit at 5,99999 here, then when this ran, it might actually extract cabs when this was actually the 6. It would be 06, because the next slice over, boom, we get the 6 seconds, and then our timestamps all work because this thing was extracted at, technically speaking, 5 seconds 99999. Rounding up to 6 is okay because the next one extracts at 6, and this is then at 6.0001 or whatever, still equal or greater than. So why don't we go take a quick spin and see how these files are being extracted from merge modules real quick, and see if we control that timestamp. I don't know that we do, but it's been a long time since I looked. I think we're going to find that the merge module API is what we're using to extract it. But let's go ahead and look at that first, and then we can start thinking about how we want to solve this. So that first things first, let's go do that. Go over to the Wix toolset and into the extract module files command. And then we come in here and we say, for all the merge symbols, we will create facades for them, so file representations in our world, and then we extract files from the merge module. So let's look at that. What do? We get the language, we create a path to the merge module. No, we create a cabinet, and then we extract all the files from it. This is interesting. Are we actually using DTF here? No, this is core native. All right, so good. Good. So this is calling into our cabinet code inside the Wix toolset. I was going to be really surprised if we were using DTF for this. And then we call the extract method, which calls out to wixnative.exe, which then does a run on the extract cab. So where did we open the module? Oh, okay, so we used the merge interface here, the IMSM merge, this is the provided by the Windows installer, to extract the cabinet, which is good. And then we call out to our code, then extract the file. That's cool. All right, cool. This means that there's actually hope for us to be able to get in here and fix it. Because what happens, all of the cabinet extraction code in the Wix toolset is isolated off in this wixnative.exe. So it's a native code because we have a lot of native code processing, or rather all of our cab handling has been done in native code inside the core Wix toolset. And our native code handling has advanced features. In particular, it has the smart cabbing, where it can find that you have the same file twice, or the same bits, different files, but the exact same bits. So underneath it's the same file, but to have different file names, they need to be in the cabinet twice in 2 different locations in the cabinet, but it's the same stream. And we then do some fix-ups inside the cabinet so that the cabinet only stores a single set of compressed bytes, but it actually has multiple names aside. All that was done in the native code, and we never tried to re-implement that in the managed code. So that's cabinet creation is an example of one piece of code that is in native code. There's other things that Wix native does, but the cabinet is one of the big things. Cabinet processing is one of the big things. And the reason we broke it as a native XC is the idea that maybe we could, well, there was some interest early in Wix 4, and it's kind of died down now. We don't have people working on it, but there are some people really interested in providing Linux support. And so by extracting out that piece, they could go out and replace Wix native and re-implement the cab APIs such that they would run natively on Linux, and then the Wix toolset would be able to build MSIs on Linux natively. It's definitely doable, but people aren't finishing that part. But Wix native exists for that reason. But we own Wix native, and we have the extract cabs. So what I want to do is go into the extract cab code and look at, and we're going to go dig. So we're going to go dig into the native code here and see if we can find out why it's why our timestamps are not at a high enough granularity. What's rounding them off here? So this extract cab command gets processed by the wixnative.cpp, but it ends up turning into the extract cab code. So we'll just go jump to that. And as I mentioned, we use our library to do our cab extraction. So here you can see there's not a lot of code in here. We essentially just initialize the cab code and then we extract it. And we call extract into that function, which is part of dutil. Because we use cabs in many different places, also in Burn, that code is shared in all these places, so it's over in dutil. And I'm just looking at this real quick to make sure that there's nothing else special here going on. But it looks pretty simple. So that means that we want to go look into the dutil code. So let's go ahead and open up that code now. That's over in the dutil project. I'm just going to use code for it because it's all native. Libs dutil. All right. We'll open the dutil folder here and let's see what we can find in the dutil code. We want the cab utilities. Let's go ahead and look at the header files first, because we're going to have both cab creation and cab extraction here. So I think we want this one. Yeah, so there's the cab extract helper function. Yep, and you can see there's the cabinet, the file that we want to extract, the directory we want to extract to, if there's any progress, just be able to send progress as it's doing so, any context you want to pass back to your progress, and then the embedded offset. So that allows us to extract cabinets out of the middle of other files without having to extract the cabinet first. Not useful in this case, but useful in others. So that's that header. We'll jump back over to look at the Wix native code again and make sure everything lines up. So there's our cab path. We're going to pull out star, so all files, to the output folder that got passed in, and then we're going to send this progress, which basically just prints out the beginning of each file. Okay, and then we have no context to pass to ourselves, and we're starting at the beginning of the cab, the 0 file offset. All right, great. So let's go look at the actual cab extract code. Yeah, all right. Now, this cab extract code is all built on top of the cabinet.dll built into Windows, which is the thing that would have to be recreated on Linux if there was someone that wanted to make Wix work on Linux, which would be fantastic if someone wanted to do that work. But because we're using cabinet.dll, it's all embedded in there. And the cabinet.dll has an interesting API. It's very callback based, called FDI and FCI. I don't know what the F stands for, but compression and decompression interface is the CI and the DI. So we're going to say cabinet operation extract this file. Let's go look at this. And I've not been in this code for quite a while, so let's go see how it rolls. All right, load cabinet DLL, let's get the path and directory and file name and convert to multi-byte. Oh yes, so cabinet DLL definitely wants to operate at ANSI in a lot of cases. I think I remember that. So we have to do all this multi-byte hula hoops to make sure things work here. All right. So then we're going to go down and we're going to say, hey, do the cab extract callback. And we'll call press. Yep. Let's see. I want to jump back. I want to make sure that that is what we passed in. Let's go back up. Whoop. Cab extract. I lost cab extract. cab extract, and we are passing in null for the notify, which means we are doing cab extract. Okay, great. Just want to double check. So we're coming in the null, cab extract callback, and then we call off to this function pointer, which is the function pointer we got from cabinet DLL called FDI copy, which is F for whatever that means for cabinets, and then the decompression interface copy. So essentially copy these files out, pass it its handle, and all these other kinds of things. So what we're going to find eventually in this cab extract callback, hopefully, is the creation of our file. Cab extract this, all right. Copy file. So begin extracting source from file. So this is probably where we're going to create our file. And here it is. So if our file that we're supposed to extract is star, that means we extract it. Or if the file that we're supposed to extract matches the thing that we're going to extract, yeah, we're doing that. And here it is. Create DOS time. And then local file time to file time. DOS time, local file time is not going to have the fidelity required to keep that file time for us. Yeah, so here it is. We, out of the cabinet, get its date and time and convert that to local. The things that I thought this would pull it out of the resource out of the cabinet itself. All right, well, let's see where this takes us. So that puts all the result into the file time, the local file time. Fine, create this. We're going to open file with retry, and then we're going to reset the file time to the file time that we got from whatever the notified date was. Then we set the file pointer to the beginning of the file. We set the end of the file. No, we set the file we set the file pointer to the size of the file from the beginning. We tell the operating system this is how big the file, then we go back to the beginning. So this is essentially a way of marking how large the file will be at the end. It's an efficient way of allowing Windows to pre-allocate space on disk for us. Say, hey, here's our file, it's going to be this big, we're going to start writing to it. Just letting you know. So that's what that does. So this is the thing that's the trouble, is the set file time right here. And we're trying to set the file time to the file time that came from the cabinet, the resource in the cabinet. And that timestamp is a DOS timestamp. Oh, right. So as I was walking through this and talking my way through it, I was like, but that time is very close to our current time. But that's because we just built the merge module as part of our build process. So essentially our build process is happening so fast that even the file that got put into the cabinet. All right, here's what's happening. So we build the merge module as part of our build process. Now we probably need to bring that up. Let me see if I can. All right, let's go find that code. All right, let's code Wix4 into the tests, source tests, Wix, and okay. And let's go look at the test data. I forget where I keep forgetting where I put these. Wix proj, and we're looking at the Windows, the VCX proj Windows app. We'll open up code right here. All right, code with its handy dandy file explorers for us on the side. Okay, so we're looking at VCX proj Windows app, and if we look at this Wix project, this has a project reference to this merge module Wix proj. This is our big test that we've been doing since the beginning. We've been trying to track down, we've been trying to get this project with all these references to different types of projects to build incrementally. All right, so when we build this, it says, go make sure this merge module project is built, which is Wix proj module. Wix proj module, the yellow one here. So we tell it to build this. And this module includes the CS proj Windows Form netfx exe. All right, so that file 00000 thing that we see basically with this fake GUID right here gets built. So we build the XC, we build a merge module, insert the file into a cabinet, because that's what you do with merge modules, and that cabinet gets embedded into the merge module and sent over to us. All of that is happening such that the date timestamp we're getting on this file is 220202120706. The merge module build is so fast that it ends up being put in there. Yes. And when we extract it, it gets stored in DOS time, which ends up truncating or losing, rounding up, I guess, losing some of our local time, or losing some of our detail. So then when we ask the cabinet API, hey, what's the date and time for this file? We write that to disk. And it ends up being whatever it was built at, which is all happening. Essentially saying this build happens very, very quickly and all within the spans of these seconds. So this set file time is what's giving us a truncated date time. All right. So I think we've got to the bottom of it. Now the question is, what's the best way to solve it? I don't know. All right, one option is to reset the time of the files in the compiler during the build process over there. So that we would go back to having a real thing. The thing is that this allows us to have the file time of the file that was put into the merge module. And I wonder if that's what we want. Like, do we want to preserve the timestamp from the merge module? And the answer is, I think we do. So if you get a third-party merge module and it has, like a text file in it, then you'd want to make sure that you got it. You'd want to try to have its timestamp left from whatever they built it with. Now, in my case, I'm building it every time, so I see the timestamp keep changing. But if I had a merge module checked in, then that file would be, that old. You'd be able to know that, yes, we didn't modify it in our build process because it just came out of the merge module with the timestamp from the merge module, and it's that. So I don't think I want to avoid this behavior or prevent this. I don't want to change this behavior. I want cabinets, when they extract files, to set their timestamp to whatever the cabinet says their timestamp is. That's the most correct thing for this code to do. And I don't think I want to change that timestamp as part of the build either. Yeah, I don't want to change the timestamp of the build. The timestamp of the file during the build, because I want it, again, if it comes from a third party, you want the timestamp of the file to be that, not the timestamp of your build. You want the timestamp essentially of their build when they delivered it, not the timestamp of your build locally. All right, so given all that, that means I can't change the time here, which does expose us to an interesting problem in that if this file, let's say someone created a merge module and their clocks were really skewed, like, I don't know, into the future, like 10 years, I don't know. Or they really were just messing with things. Technically speaking, you could create a file, put it into a cabinet with a timestamp into the far distant future, and then whenever we'd extract it out of this merge module, that file would come out, we'd set it on disk, and we then set its timestamp to 10 years in the future, and that thing would make our build dirty every single time. All right, so I think what that says is that we need to not include the merge module's extracted files in the timestamp calculation at the end. Now, this is something I think we mentioned once in the stream before as an option. It's like, should these files that are extracted from the merge module be used as inputs into the timestamp calculation? And I think even then I was arguing, no, they don't need to, because if the file is in the merge module, well, then the merge module's timestamp would have to change if the file inside changed. If the file changed inside, you'd have to create a cabinet, put it inside the merge module, and then poof, the merge module will have a new timestamp. So we can use the merge module's timestamp as the input to the build process. I think that's probably the next answer, is to go and do that change to remove the merge module's files from being included as inputs. Now, the challenge with that is that they're probably being pulled out in as inputs because they're basically saying, hey, these are the files I put into a cab. Yeah, there's probably being listed as an input because it's just, we can put all sorts of files into an MSI's cab. They come from merge modules. They could just come from files on your disk. They could come from anywhere. And so it's probably that they should not be listed as, yeah. So we're gonna have to figure out a way of filtering them out. Fat time has a resolution of 2 seconds. Oh, thanks, Bob. Yeah, that really does not give us any hope. DOS date time is essentially file allocation table, whatever. Fat time. Yeah. Does clean remove those extracted files? Yes, the files should be, they're tracked in our file rights. We can double check that, but it's tracked in our file rights, therefore they should still be there. But I think we're going to want to remove them as inputs. So all of this also has me thinking, well then what happens if the merge module itself has a timestamp of far into the future? What does that mean? Now, they're modified, I guess they're brought down. So in that case, like you got the merge module from somewhere. So that means that when you got that file, it got a timestamp of something in the future. You could fix that. You could say, oh, I'm going to fix the timestamp on that and put it into the future. All right, so that seems like less of an issue. You could have it with any other file that becomes an input to the cab. The file could be, yeah, I guess the file could again have a strange modified timestamp. So if you're doing really screwy things, you could end up with files that are designed to break incremental build here. Here we're breaking ourselves because we're using DOS time. Okay, I think we're just gonna have to let that, I'm gonna let that go for now. I'm just gonna not worry about that one for this moment and think about how I'm gonna filter these things out. Okay, great. So that was fun. We did a quick foray all the way down from Wix, all the way down into native code. All right. So let's see. So this is our Wix native. We're done here. Console initial, yeah, that's Wix native. All right, and where am I? This is cabinet, so we're fine there. Okay, now we're back into the core. Oh, this is the extract merge command. Yes, so we are back into the core Wix toolset, and we'll jump back out all the way to where this is called. Okay, so I think what we're looking at now are what our tracked files are. I think is that all we care about? Yeah, that's what we care about now of our tracked files. Less our file transfers and more our tracked files as things are created. Yeah, okay, so let's look at create cabinets command real quick. So he has his list of tracked files that he's going to maintain. Let's go see how this is used. Oh, it wasn't for a second. Right. Oh, so we add the cabinet as an intermediate file. That's fine. The cabinet as a built output. Okay, so wherever we're gonna, oh, that's the destination. Yeah, wherever we're gonna put it. This is cab spanning, which is actually probably my next thing to work on. It's not working. Okay, wait a minute. So that says that we do not track all the files that are being included. Let's see here. Create a work item, file resolve. Okay. Yes, so we've got all these file facades in here. Okay. I don't see us tracking each of these files as an input. Okay. All right. Let's take a quick look at our tracked file. Let's see. Do I have a build left over? Oh, I didn't grab the tracked files. Let's see. If I do an incremental build with no edits, I want to see the tracked file at this point. So let's go ahead and run this again. I want to see what the tracked file looks like for this so we can see what our inputs and outputs are being. Results, outputs, view. And I want to go grab this folder, this temporary folder where things are being put. And in our OBJ, and in our debug, there we go. Yes, bind tracking for our E and US. Let's just look at this real quick. All right, so what was inputs? These are our built outputs, the cab, the MSI, and the Wix P2B. That's correct. Input was the Wix extension, fine. Input was the exe. I think we referenced that directly. That's fine. Input was a library. Yeah, we referenced that. Input was the merge module. That's fine. So if we just take these two inputs out, then this must be added when we're extracting the files. Okay, so we could take those two inputs. That will be interesting. So if we don't list them as inputs, well, let's go do that. Let's find out where they're being added as inputs. Thank you. Go ahead and finish running. Are you going to pass this time? Nope, didn't pass this time. All right. One thing I found is that this test here that we've been running, this incremental back-to-back build that should be a pure clean incremental, is failing more often now than before. And I don't know if it was because of the additional logging I added or something else. I don't know. But it seems like it's happening much more regularly now. I've pushed it right over the threshold to make it happen every time. Okay, so back to the Wix code. Let's go look at maybe I missed it as the extract. That's extract embedded files. Let's, not the one we need first, but, oops. Come on, go there, please. Oh. Which of these is an implementation? That's the implementation I wanted. All right. Yes, so here we are. All right, this is the base URI. So this is the Wix lib in this case that was extracted from a, this tracking file says this Wix lib that came out of the extension. This is the path to that extension. That's what that gives us. Okay, so we don't have to worry about that one. Unique ID is embedded file ID extracted here, and then we track this file as the output path as an intermediate. Okay, great. So the files that get extracted there, we're good there. All right, so tracked file type, there can't be that many. Put this over on the correct windows, please. Or tracked file type. Oh, find in files. What did it just do? Tracked file type, thank you. Input. Let's see how many places declare an input, because that might be the fastest way. Extract embedded files command. Oh, yeah, that's what we're just looking at. It's like, right, yes. Librarian, process payloads. That's bundles. We're not worried about those yet. We will have to eventually. They are. Tracked file. Here they are. So this is the merge module itself, right? Yeah, so this is the merge module itself tracked as an input file. Oh. Okay. Here's where it's at. And we're all the way back to here. I kind of hoped that we would get here. This is the take every single file that's listed in the Windows installer database, that's the file facades, and add them as an input. All right, so we are right back where I said we would be, where we'd have to filter out things that came from a merge module. Yeah, to prevent them from being listed as inputs as well as the intermediate file they were. So that's one thought. If a file is an intermediate, as in it got extracted from some other file type, like it got extracted from a cabinet because it was inside a merge module, it got extracted from an extension because it was inside a Wixlib, it was in a Wixlib, it got extracted. All those will be intermediates. Intermediates are meant to be cleaned. They came from some other process to create them. Is it safe to say that intermediates should never be listed as inputs? Because that's one way to solve this. If a file facade came from an intermediate file, then it is not an input. There must be, so if we say that, then that also means that there is something else that is an input that tells us that the intermediate changed to essentially proxies the timestamp for that intermediate file. And that seems true. The intermediate files are all generated through processes based off of the inputs. In our case, the inputs are the source code, the Wix source code that gets compiled and turned into all these things. Of course, if you change that, then we have to rebuild the MSI. The input is also the set of extensions, because they may provide data. So anytime an extension changes outside of your project, outside of your source code, well, if that changed, then you'd want to rebuild your MSI. Merge modules are also outside of your code, and if they change, then you'd want to make sure that you get their new logic and their files into your process, but they produce intermediate files. Binary Wixlibs also are listed on the command line, also listed inside MS Build project. So they're listed as inputs already in the targets. So far, all of those things have proxies. What are other things all right, so we haven't talked about how the software tag gets generated. The software tag being the ISO 1970, 770, I forget the number now. Well, it's been so long. But generating one of those software tags is a process we do that generates an intermediate file. If an input contains embedded files, those files extracted to intermediate should not be also inputs. Yeah, I agree, Bob. What I'm actually trying to go one step further, whichever, and say that all intermediate files should never be inputs. Even though they may have, the intermediate file very likely contributed either to the MSI, like an IDT file, or one of these extracted files from somewhere that got put in the cabinet. Further, thank you. See, I wanted to go with further. I'm always afraid to use further. I feel like I feel stilted when I use further. Anyway, so I'm thinking if a file is listed as an intermediate, that means it got generated during our build process and therefore cannot be an input because we processed it during the build process, and there is something else in the build process that chose to generate that. And the only reason that we would generate it again is because one of our other inputs would cause it to be different. The Wix source code, extension, merge module, so on and so forth. That sounds right. That really sounds correct. Is that intermediate files don't ever, for MS build ins and outs, it shouldn't include files generated during the Wix XE invocation. Yeah. And that's what intermediate files are those things that are generated during the Wix XE invocation. And they mostly exist so that we can, as Zach asked, do clean. Right? We need to track them all so that we can clean them. Which is good. All right, so if we say we're going to filter out intermediate paths, I like the sound of that. We have the data object here. I'm gonna look at the file facade real quick. So sorry, what I'm thinking about now is actually while we're gonna go jump into this problem and start filtering out intermediate tracked files while we're creating inputs, I wanna also look at this binary and icon table problem here. So the issue here is that, well, if you have a binary file and icon file, those are external files, and today the Wix toolset is missing those as inputs. Those are direct inputs. They're a file on disk that then gets input into your build process. We're missing that today. That's not good. We should catch those, and we can catch them by reading the data, the Windows installer data, and for every object row or field, for every object field in there, that will have a path to disk. That should then be a file that was an input, or it's an intermediate, which then we should filter it out. So my thinking is that we should be able to kill this to-do and this problem we're having all with one stone simply by solving this block of code. That is true. This is not sufficient. We need to essentially create a function here that says calculate the inputs from the Windows installer data, which would be great. But what I wanted to do was make sure that file facades so the file facade also says if it came from a module. We could filter out ones that came from modules, and that would solve this problem that we're seeing right now, but only because it comes from a merge module. It would not solve our problem for other things like Wix libs and extensions. Okay, I want to see the actual implementation of file facade. Yeah, so it does have a file symbol backing it. And also have a file row backing it. I'm looking for the source. If the file row is null, then use the file symbol. Otherwise, use that. But that's a read only. All right, cool. What I was looking for was whether the file facade had a way of updating the path to the file that bypassed what ended up in the Windows installer data. And it looks like it does not. So the quick digression, since file facade is probably new here, file facades are wrappers around all the different ways that you can represent files inside the processing. It's not simply this file ends up in the file table. There's other cases where we have to do more complex things, like when they come from merge modules, we create the file rows before because we read the merge module and get its file table out, we create those file rows before we create the file rows for the things that you authored, for example, directly into your code. So this allows us to create a facade, something fake over that says, hey, this is a a representation of a file that will end up in the MSI, and I just want to make sure that it would get backed correctly in the end. And it looks like it does. All right, so what I want to do now, if the file rows end up with the correct time, they have to end up with the correct times row in it. That means that we can just go through and look at all object fields. Okay, what are we going to do? We're going to write a function. This dot, what are we doing here? We're going to get input, track input files. I think I don't know exactly what it's called. It's something like that. I think it's like track input files. And we pass in the data, the Windows installer data. And we will get back input track files. And then track files dot add. Yes, that please. Thank you. Okay. And then this code will go there. Yes, please. So IEnumerable I track file. All right, that's close. Well, usually we put these in order that they're in here. Okay, good. Resolve media, create Wix out. Is resolve media used? Where is resolve? Oh, it's used twice. Interesting. All right, we'll put it at the end. Don't know why I hit that. All right, let's see here. Track input files. Yep. Now we have to go through the data. No. For each, please. Data dot. Yeah, I'm just going to go through all the tables. Whoa, that did not do the right thing. For all the tables. Technically speaking, for all the rows. For all the fields. I can do better than this in a row, but fields. If field dot please. Nope, not fields. Field dot column type equals column type dot object. That means it's something on disk. So let's go ahead and get that. Field. Man, I cannot spell field today. Field as object. As string, I guess. Because it's stored as an object. Yeah, I guess it's just a string at this point. No, there's object field. Yeah, so. Show me object field. Yeah, I don't need most of the things on object field. Never mind. As string will be fine. All right, the path will be the field there. All right. Before we get started, I want to take, I guess I'm going to need to pass them in. Right? Yeah, okay, fine. I'll take all the track files at this point in time. Okay. And we're going to say, what are we? Intermediate paths equals new hash set, please. Of, yeah, you'll figure it out. of tracked files where t dot type equals track file type dot intermediate, or t dot type equals track file type dot temporary, because we should not be referencing temporary files as inputs either. I don't know that happens, but we're here. Select t dot path, please. Yes. String comparer dot OIC. Ordinal ignore case, because they're file paths, and this is Windows. Are we not happy? There, I guess we're happy now. I guess it didn't want to guess. All right, so now we have our intermediate paths, and we can say if not intermediate paths contains path, yeah, sorry, thank you, magic code, then, oh, we need a track files var, track input files equals new list. Yes, 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 thank you. Add, and it's not, it's all right, yeah, we're fine. Our field, oh, don't we have a source line numbers, sorry. What? The field doesn't have source line numbers? Nope, I guess not. How about the row? Source line number, yeah, the row has source line numbers, that makes sense. We do not track source line number information down to the field, although that might be cool, but we don't. Now, that should be sufficient to get all of the, no, how's that right? Tracked input files, that one, yes. All right, so what does this say? This says we take our Windows installer data and our existing set of track files. We take our track files and we get our intermediate, I guess I could call this intermediate, and temporary paths. We get our intermediate and temporary paths. Yeah, ignore case because it's Windows. And then we say, we go through all our tables, all of our rows, all of our fields in those. If the field is object, then do that. So how about we could do row dot select many table dot rows. And then this, we can do fields where f dot column type object type that, get rid of that if statement. Oops, too many, there we go. All right, so go through all of our rows and all of our tables. For all the rows, for all the fields in those rows that are of type object, then get the field as a string, which is the path, contains the path value, and then intermediate and temporary contains path. So we will then say, if it is not an intermediate or temporary path, track it as an input. Return tracked input files. And tracked input files. IONumero tracked files, add range. Zoom, zoom. All right. Are we getting somewhere? So Zach and Bob are with me. Is there anybody else out there besides Zach and Bob? Hanging out, having fun, lurking, keep it nice and quiet. So what I'm doing, I should bring InCrunch over. I attached it to the side here before. I'm sitting here waiting for InCrunch to go ahead and run, do its thing, do its magical thing. And it looks like I'm all green. Oh yeah, my OK progress got lost. There we go. That's too big. Okay. It is happy. It means all my tests passed. We can ignore all these warnings. They're basically saying things like Tracked input files or input track files? Yes, so I think it's tracked input files, right? Tracked input files. Track input files, tracked input files. Tracked input files. I got it right the second time. Okay, you can see the test running over here, 19%. Well, that's interesting. Let's go ahead and build this again. Kind of made a mess of things here earlier, so oh gosh, yes. All of my temp folders gone. Yeah, okay, fine. The Incrunch folder's gone. Got it. I understand. Let me go ahead and clean things up a little bit. Like I said, I made a mess of all my files as I was trying to get all these things put in the right place. All my different monitors here. Let's see. I don't want to do a full clean, so I'm doing like some surgical cleans just to make sure that everything is... Nope. Sorry, I didn't want to cancel. No, I said pause. Okay. I've never hit pause before. That was kind of cool. Not what I wanted, but interesting. Okay, I just want to make sure these things get rebuilt. All right, so let's go ahead and build. Time this, clear that Wix. Okay, this build will take a minute and a bit. I'm closing this back here. We don't need that. Let's see. While we're doing this, we're going to close this as well, get rid of these timestamps, and I'm going to go get another whole new set of timestamps, and hopefully we see... Actually, the timestamps are still going to be busted. What we're hoping to see instead is better behavior, because we are not including those merge module files as inputs anymore. We're not including any intermediate files as inputs. We're not including, what else are we not including? Intermediate or temporary files as inputs. Build. And then go here, Wix, debug, publish, this. And what I'm doing right now is just to make things a little bit faster. I actually copy these over top my location where they're built. Okay, so that's going now. Test data, that. Let's bring up our tests again. And this, I think, is the moment of truth. Bring Crunch over here again for you guys. And the risk progress. Now in this case, I'm only running run test. That failure is left over from last time, not this time. Hey, we have green. That means nothing because we've had green here before. Instead, we're going to run it again. Zoom. Go. Go. And that's good. Now we're going to run it again. And go. Usually at this point, one of these would have failed. That's good. Oops. Yes, I know. Go. Run again. This is much better than last time, I think. Last time I was pretty confident we had issues by this point. Oh. Me, oh my, oh my, oh me. All right. Well, at least through all of this, we should have also picked up that little to-do that we hit, which included the icons for binaries and, or the binary files and icon files, which we're missing and we don't have a test for. So getting a test for those will be interesting in here. Technically, probably should have run the test and verify that they failed first, but red, green, Rob, red, green, not green. Anyway, what was I gonna do? Oh, I was gonna debug this real quick. And I want to go look at the tracking file and see what it looked like. What do I expect to see? I expect to see that the let's see, that the results, no, not, I want the results, not the method call. Thank you. Sorry, I can't talk and find fiddly details at the same time. What do I want to see? I want to see that the inputs, that the tracking file inputs no longer include that other data. Oh, I may have closed it. Yeah, I already closed it. All right. Oh, too far? Yes, too far. E and US tracking file. There we go. Yep. There we go. Our inputs now look like we said they should. They include the containers, but not the files that get extracted from those containers. And that is goodness. And then there's these intermediate files in here. Yep. These are all those intermediate files that got extracted from the... Oh, interestingly, I think these are custom master DLLs, icons, and binaries. Funny enough, these weren't showing up as inputs before because of that bug where we weren't including binaries as inputs. That's why only the merge module and the DLL were showing up as inputs. And it all makes sense now because we had those two listed as inputs. Huh. It's nice when a plan comes together. Gosh, this looks like correct, proper, what you would expect to see. This is fantastic. Fantastic. All right, so we spent 90 minutes last week and some good amount of time before that, I think, right? Getting to this point. So this feels like fantastic amounts of progress. Let's go write a test that does rebuild. Yeah, I think there's now, let's go write a test that does edit these files and see if we can validate that to make sure that the files do rebuild. I guess we should make sure that it doesn't always incremental build and skip all the work. But let's see here. Okay, let's close that. We can close this and let's go ahead. All right, that's the first, generate hashes. All right, let's see how fast this is. Here we go. So here it says 18 milliseconds is the last thing. Let's see what it takes to get over the restore and build statement. It should be small. No, it's not small. That's a whole second. Now it's got me nervous. All right, I'm gonna go look inside the result at the output. Premature celebration, possibly. Let's go look real quick and look at our build log. Big enough? Big enough, I think. Yeah, okay, Wisproj. Down, 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 down. Core compile. Skipping, because all outputs were out to date. Man, so what took so long? Duration, yeah, it was 1.6 seconds. Top most expensive task. Oh, restore. Update project reference metadata. CL, oh my goodness, why did CL build again? Okay, so that's the native code. So I guess actually it did evaluate our project and all the projects we referenced within a second and a half, a little bit over. Restore task has to do, I guess, work. So that's not even 20%. Okay, and then update project reference metadata. Oh, this is ours. Interesting. Okay, so that's ours. All right, I'm gonna do a quick digression. Copy, drop. I'm gonna go look for that in a second. So this is actually ours, so we can see what part of that is taking too long. CL, yeah, there's no hope for the C++ compiler, but even 79 milliseconds. Get project, that is 45 milliseconds. We're kind of getting down to this. Well, this 190 is second. Let's go look and see what's going on here, because this is our target. 3 milliseconds. Oh, it is calling off into an assembly. Interesting. All right. Okay. So this one took 3. Where's the other one? There it is. This says it took 3. And this one? Where is this one? There's the one that took 187. Update project reference metadata. Parameters. Project references. There's our 3 project references. That's more like what I expect to see. Interesting. So this task is showing up in the incremental build, right? I know I'm starting to kind of micro-optimize a little bit here before getting all the other things done, but I just kind of want to put a pin in this as a thought of what is the next thing that happens here. Is there a way to not have this run every build? Because it has no inputs and outputs right now. The thinking is that this task is really fast, but it's showing that it's not. Well, it's fast, it's 190 milliseconds, but that maybe if we could avoid doing it, that would be even better. Okay, I'm not sure how to do that because this calculates data and generates data that is necessary for everything else to happen. Okay, well, I'm gonna keep that in the back of my head, that this target running actually shows up in the log file. And maybe there's something in the code that can be optimized to be faster, or maybe some way to condition it out. But all right, okay. So that was a fun little digression, but we did see what we expected, which was way down here, wherever my core compile is. Where's core compile? Core compile. Because I'll update all files, inputs, outputs. Inputs, outputs. Actually, that's the merge module. We're not low enough yet. Got to keep going. Inputs, outputs. Source code, more source code, these things. Oh, you know what? We need to put the Japanese thing back in. Okay, we need to go do that real quick. Because remember, I renamed the Japanese Wixel to wixel.test to get it out of the mix. So by putting it back, then we will be able to run this test with localization in the mix. But this looks correct. Why am I doing this? There we go. That's much better. There's our Wixsub that we referenced, the merge module we referenced, the XC that we referenced, and then the extension that we referenced. This was generated as part of the build. And then the all targets, I guess, that we got included with the rest of everything else. Interesting. And then cab, and then our binding file. That's cool. That's cool. All right. I said we would bring Japanese back, so let's bring that test file back. It should be right here. Let's go ahead and open code from the root. Is it here, I think, that I've been opening them? No, one more. Code up one. I thought we would open one. Did I do it from the very root? There we go. I was trying to find the to-do.txt. Normally when I open it in the right folder, the to-do.txt comes up. All right, so, okay. Episode 9. Oh, we have the cross-language pollution of build inputs and outputs. I totally forgot about that problem. From this. Yes, look at that. Investigate if this target can be skipped completely during incremental build. As it shows up in clean incremental build performance. All right, there we go. Clean. All right. So let's bring the Japanese code, the Wixel file back, and get that building. Wait, where am I here? Source. Oh, right. Test comes before Wix. Test projects. Nope, sorry, test data. Windows app. There's our Wixel.test. Simply by renaming it the correct thing. Make sure that we're not ignoring it. Yep. Hopefully that brings it back into. Oh, I see. Excuse me. Can I double click this project? Are you the problem? Yeah, you are the problem. This content remove. When you delete things from Visual Studio, they start deciding they have to add those for you to hide the things. All right. It's back. There's Japanese. Build, be clean. Just work, please. Please? Please? Ooh, okay. That was good. Next one. Here we go. Run again. Come green, be green, be green. Yes. Run again. I know. So scientific. Proving that something that doesn't happen all the time doesn't happen at all, therefore is fixed. It's really hard. But it definitely happened more often than this, so I'm feeling pretty good that we've got it. Yeah, I think so. I think so. All right. Oh, it did open it. Interesting. All right. We want to write a test now. Okay, so now I want to basically take this test, run it again. Can incremental build with edits. Okay. What's the failure over here? Failed to write the log file. That's fine. We'll let the thing catch up. Run it again. Okay. Can't build package native Windows application app with edits. There we go. Now we're in a good spot. Okay, that is not what this is doing. So this should be an incremental build that does work because a file was updated. Now the question is, what file can I update? Any of the inputs, I suppose, but I don't want to modify the existing files. I guess I could just, no, I should be able to just touch it, right? Yeah. I can just touch the project file or one of the source code files, and that should do it. All right, so let's try that. The project directory. I don't know if I ever, how do you modify the timestamp on a file? What's the easiest way to do that? I don't know. Our package WXS path equals path combined project not bin project directory really? Oh, project path. Oh yes, that's true. Project directory. Oh, I just can't spell. Package.wxs. This is interesting. I want to compare these and say they're not equal. I'll have to figure out how I want to do that. All right, I need this test failing first so I can, because they're not going to be equal. How do I touch a file after I do this? File dot. I want to write. Oh, set last. That's perfect. Set last write time. Duh. Let's do that. Package wxs path. Thank you. To date time. Can I say now? Probably. Really? Oh, I don't have. I'm not using. I really am not been using system. All right, I guess so. Date time now. Let's see if that's enough. All right, go test go. There we go. And this one failed because we're building these in parallel and it doesn't like that. Oh, I'm building the same project in parallel, probably. Yeah, I figure out how to not make these tests run in parallel. Because they're running in parallel, they're both trying to write the MS build log, and that's not happening. Whoa, wait. All right. Oh, no. Oh, all right. We've hit quite a mess here. Yeah, file info object Zach probably would have been another way of doing it. Let's see. So the issue here is that I have both of these tests. Both of these tests are running off the same source code. And because one of the tests is modifying the file, that it may interfere with the other test. So, makes it hard to use the exact same project to do both an incremental and then an incremental without edit. So do I need to create another project? I guess I could. What happens if I pick this web application? I don't know. I think I might be taking a bit off here. Let's copy. Why couldn't I just copy the? No. Why can I not? I can't do anything. Oh, it's a link. Is that why it's upset? I guess so. All right. It won't even let me like highlight copy it. All right. You're gonna make me type it. Watch me type. That's dangerous. Wixproj package cs proj web application net core .wixproj. Such long names. All right, we should get past that. Then hopefully this build. I guess we gotta see it build first. Can build. Okay. Whoa. All right. Let's can build a package with net core web application. Web app is fine with edits. Web application net. No, it doesn't matter, but I'll just clean it up. Hey, look, Windows really doesn't care about paths. Okay, let's take this out. And let's see if incremental build works real quick. Make sure that does work on here. Okay, everybody's got to run. Project directory name is invalid. Okay. Wixproj package csproj. Oh, met. Man, I thought I fixed that. Trying to capitalize it and putting an M in there. All right. Thank you, Zach. Oh, okay. Okay, so I'm going to be honest. This does not completely surprise me. Because we're calling a web application, and to do that, we have to call publish on it. And I wasn't sure that this is going to work anyway. investigate if dot web I'm not sure we can incrementally build .NET Core web applications. So this isn't just the Wix, this is building the .NET Core web app, or rather publishing it to get it all laid out. Is not incremental. It'll build again and again and again and again. So this may not be possible. Okay, so I guess we're back to here. I don't know. I'm back to this. I need this guy with edits. Okay, this will all pass now, right? You and your parallel build. See if I run you independently. And, ooh, did I speak too soon? There we go. Yeah, it's green. Okay, good, good, good. All right. So I guess I need to create another project. Or I need to get in here and get this test infrastructure in place that will allow us to copy the source code somewhere else, do all the builds. Oh, copy the source code is interesting because you actually have to copy all the projects and do the build there. Have to build or copy several projects to make that work. Or just copy one project that's designed to be edited. That might be another thing. But this whole clean everything is not great either. That's because we're building to the same location where all the code is. All right, I don't know. I have to sit down and think about this for a while. And I've got 4 minutes left in today's episode, and I'm not sure I'm going to do that right now. I kind of just want to take a moment and celebrate the fact that we actually have this working at all. That it's like, yay, something is working. Let's go ahead and leave us in the, as they say, parked on the downhill. Have us so we're pointing in the right direction to do. This needs to be changed to compare to ensure the hashes are different, but the files are the same. I guess that's a thing to do. Yes. Yes. We can do that. That would work. Let's try to write that real quick. We're going to unpin. All right. Did I unpin the other one? All right. Unpin this. We're only running tests automatically that are pinned. So let's bring, yeah, okay, this guy's back. Good. We're only running this test now. So I should be able to get this guy. He should fail because I'm modifying the tile stamp, but I'm expecting him to be exact. Boom. Excellent. All right. So what I want to do, second built files, second hashes var. Let's see. I want to var first relative paths equals. Okay, I want this part. Okay, I want part of this, but not the other. All right, here's what we're gonna do. I'm gonna do that. I'm gonna do this. First build file is select this, trim start, and we're not getting the hash part. Boom. And then we'll keep that part. Relative paths, first hashes. Boom. Okay. Then we're doing the same thing here. Second relative paths without the hashes. Okay. Second relative paths. So I want first relative paths to equal second relative paths. I want that to be true. So I want this red X to stay. I want this to be green. Go. No, not there. Don't die there. Wait, go, go, go. Boom. Yes, 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 yes. Perfect. That is what I want it to say. And then I want it to say, I want to say each of these. Is there a all enumerable action? That kind of, no, that's not quite what I want. I want to, does not match. That's not quite what I want either. And range, not match, not equal. Yeah, I want each of them. It verifies that two objects are strictly not equal using the type's default comparer. Yeah, I want a collection. I want to say each of these is not the same. Does not match. Yeah, almost. Okay. What do I want to say? Not equal. First hashes, second hashes. Whoops. Okay, that'll now be green. That's not really comparing all the things that I want, though, is it? Well, it is. Yeah, showing the array in the array. All right, and that's all green now. Now, the problem is if I run all the tests in here, we're probably going to get into intermittent fail. Yeah, see, now one of them fails. This is the one. Yeah, some of these are not failing because they're all trying to write to the same files. Okay, that's fine. All right. It's been 90 minutes. It's actually been 90 minutes plus 2. I have good news. Next week, because we've landed this so perfectly, we're going to go have a special guest come in, and we're going to go take apart his installation and put it back together in Wix. He has something that's written in Install Shield, and he's asking for some help. So next week, he's going to join me. A guy I know from my days at Microsoft, and he and I are going to work through his project. So we're going to do some actual coding with Wix 3 actually, and have a little bit of fun for 90 minutes, and you'll get to hear somebody else's voice beside mine on this thing. I'm going to wrap this up a little bit more, get it cleaned up a bit more, and then maybe in 2 weeks I'll be back and we will do the final push on this thing. But we're going to take a break. Thank goodness we're leaving it in a good spot, and we will hang out next week. So it'll be fun. I'll see you guys in another week, and we'll have something a little bit different. I think it'll be fun. So in the meantime, you guys keep coding. You know I am.